So example 1 says in the diagram below, not drawn to scale, O is the center of the circle, and angle AOB measures 130 degrees. We're to calculate, given a reason for your answer, the size of angle ACB. So whenever 3 letters are used to reference an angle, the vertex of the angle is always at the letter in the middle. So the angle ACB is the angle C. So that is this angle here. Now, angle ACB is equal to 130 divided by 2 is equal to 65 degrees. And the reason for that is that the angle at the center is equal to 2 times the angle at circumference. So in other words, the angle at the circumference is half the angle at the center. This angle here is 65 degrees. Next, we're asked to find angle BAO. So that's angle A. In order to find that, you'd have to recognize that AO is a radius and OB is also a radius. So that would mean that for the triangle OAB, 2 of the sides are equal. And if 2 of the sides of a triangle are equal, that triangle is an isosceles triangle. For the isosceles triangle, the 2 equal sides meet at the apex, which is O. So this is the apex. This is the base. And the 2 base angles of an isosceles triangle are equal. So these 2 angles are equal. If we want, we could call this theta and call this theta. So 2 theta, which is theta plus theta, would be equal to 180 minus 130 degrees. These are the base angles of an isosceles triangle. The base angles of an isosceles triangle are equal. So 2 theta would be equal to 50 degrees. Divide both sides by 2. And so we get theta, which is angle BAO, is equal to 25 degrees. So we would answer our questions something like that. Notice that with all these questions, you tend to have to give a reason for whatever statement you make. That initial statement, you tend to have to give a reason for it. Let's have a go at example 2. In example 2, we're told that in the diagram below, not drawn to scale, O is the center of the circle. The angles SPT and POR are 35 degrees. This should be degrees, and 135 degrees respectively. In other words, the angle at P and the angle at O are 35 and 135 degrees respectively. So those are clearly shown in the diagram. We're asked to calculate, given reasons for each step of your answer, the size of angle QSP, angle QSP. All right, so the first angle we need to find out what it is the angle QSP. So that is the angle at S. Whenever 3 letters are used to reference an angle, the angle is always at the letter in the middle. So we need this angle here. All right, What we have to learn how to do is how to spot the theory in the diagram. All right. Now, I'm going to tell you that this angle is actually equal to 135 divide by 2, which is equal to 67.5 degrees. And this is the reason. Angle at center is equal to 2 times angle at circumference. Angle at center is equal to 2 times the angle at the circumference. Now, please look. So this is, according to that, this is 67.5 degrees. Please note, this is how you get angle at center and angle at circumference. You have a chord. One angle go to the what? Center. This is 135. And look at this now. The other one start at P. This is P. This is Q. Start at P, go up to the circumference, and then come back down to what? Q. This is S. So if you don't look at the rest of the diagram and just look at this part of it, you should see clearly that the angle at S is a half of the angle at the center, because the angle at the center is 2 times the angle at the circumference. They both start and end at the same point on the what? Circumference. One goes to the what? Center, and the other goes to the what? Circumference. The one at the center is 135. The one at the circumference, which is S, is a half of that, 67.5 degrees. Next, we need to determine, well, what is TQR? That's this angle here. Now, TQR is actually equal to 35 degrees. There are angles in the same segment. Let me show it to you. And angles in the same segment are equal. All right, let me try and show it to you why it's angle in the same segment. Look here. So we have our circle. This is my chord SR. This is my chord SR. A line leaves S, goes up to P, and then come back down to what? R. Leave S, go to P, then go back down to R. The angle here is 35 degrees. Please look for yourself, 35 degrees. The next angle starts at what? S, go to Q, and then come back down to R. Note, look for yourself, this is the one at Q. This is also 35 degrees. This is P, that's Q, they're 35 degrees. They're called angles in the same what? Segment. And angles in the same segment are equal. This is 35 degrees. Lastly, we're asked to determine the size of angle QTR. We need this angle here. Now, here's how we can find it. We can find this angle first. We can find this angle first, and whatever this angle is the same thing, because these two angles are vertically opposite angles. We could find the angle theta first, and whatever that angle is, the other one, the one that we need, which is QTR, is the same angle because the two angles are vertically opposite angle. Then I would say that theta is equal to 180 minus 35 plus 67.5. So this is 180 minus, what is that? 102.5. I think it's 102.5. If I'm wrong, you can correct me. And so this works out to be 77.5 degrees. So angle QRT is equal to theta is equal to 77.5 degrees. They are vertically opposite angles. So this is what I did. I found what I want is the one to the right, but I know that the one to the I know that the one to the left and the one to the right, they are equal, they're vertically opposite angles. So what I did is I used the fact that the angle in a triangle add up to 180 degrees to find theta. And then now to say that theta is equal to the angle which I want, which is QTR, they're vertically opposite angles.